So all your program is going to have a comment on the top explaining what the program is doing. All your functions are going to have also a comment to say what the function is doing. At the end of your program, you're supposed to have your sample run. Inside your code, you're supposed to have some comments saying what the codes are saying. There is no one character variable that I would accept. They have to be defined as a good name. I can't even talk anymore. What else? Any other questions? Are we ready for chapter 6 again? Okay, so once again, this chapter 6, somehow my last semester students had a hard time with it, so we want to be sure that we understand this good before we move on. So when we're talking about the standard input, the standard output, what does that mean? A standard input, when I'm using a cin, where do I read from? Keyboard. The standard output, when I display cout, is going to go to the screen. Now we want to redirect those things. We want to go from the keyboard to a file to read from. We want to print to the file instead of a screen. We talked about objects. Objects are the existence of the class. This is the beginning of the object-oriented design. We're going to be learning object-oriented programming in your next class, CS3A or CS3B, which is a Java. So we talk about that a little bit tonight, a little bit about this chapter, but you will learn a lot more in your next class. So we're going to be using a stream for the flow of data. So we have data coming into our program and data going out of our program. Remember, input, processing, output, IPO. So our program is going to do some processing based on the input coming in, and we're going to do some output going out. So the typical one we were using right now so far was a keyboard, using the keyboard to enter the data. Now we're going to switch it to a file or multiple files. And of course we're going to have displaying to the screen. So cin is the input stream connected to the keyboard. We're reading from keyboard. Cout is connected to the screen. For the cin, cout, we were using #include IO stream. Now we want to use our own stream. Why do we do that? So when I when my program is done, all the data, everything is going to go. So if I have some data that I want to save for next time to use it, then I can use files to write to it. Or I can read some data from some file to my program. So if I have 50 states that I have to put in, I don't have to type in 50 states every time that I run my program. I can read it from a file. So we don't have to type all the data again and again. And especially if we do that, then most likely we're going to have some mistakes or have some typing error. And also we can use the larger data. So if I have 10,000 names, I don't have to type it in every time. I can just read 10,000 names from a file. So in real life, we're going to do what? We're going to be doing file processing in the middle of the night, because that's the time that the computers are the slowest. So when we're doing that, nobody's around to type in anything. So we read from the file, we will write to files. So we're reading from a file. When we do that, we're going to start from the beginning of the file. So we're going to open up 5. We're going to start reading from the top. We cannot go back. So if I go to line number 5, I cannot go back to line number 1. Same thing goes with the writing. For now, every time I want to write to a file, I basically delete the previous one or create a new one. Basically, I have a fresh file every single time. But I cannot go back. So if I'm on line number 4, I cannot go back and write on number 1 anymore. Now, because we're going to be using these streams, we have to create some variables. We're going to be using the variables like a handle that we're going to be using to call open these streams. It must be initialized before it contains valid data. So initializing a stream means connecting to a file. So we're going to connect to a file, then we can do something with it. And we're going to talk about those later on. So a stream is a special kind of variable called an object. Objects can use special functions to complete tasks. So we talked about this last time a little bit. We have a blueprint for this for the objects. If we're using a blueprint, the blueprint is not an actual thing. So we're going to be using some functionality that we have in our blueprint in the object. So if I tell you car, you have some idea what the car is, but car by itself does not exist. I have to have a specific license plate number or VIN number or something that I'm going to have a specific car. I cannot just say go to the parking lot and pick up the car and paint it. You have to specify which one we're talking about. The streams use special functions instead of the assignment operator to change the values. These are the functions available through the objects. Now for the input file, we're going to be using pound include f stream. That is for the file stream. We have to use using namespace std. Now that we have that, we can use the class called if stream. This if stream is a class. That means some kind of a data type which has the elements and it has some functions in it. I'm going to call it in a stream. I can call it anything I want. So this object that is created right now has all the things that this blueprint was giving it to it. So if I have a blueprint of a house, I cannot just go live in there. I have to create a house. So this is where I'm creating things. So I can create 2 of these, 3 of these. So if I, like those townhouses, they all look the same because we have the same blueprint, and then we're going to have a multiple of them. Now that I have them, I can go specifically says, okay, I know there is a function to do something, but I want to apply this function to this one or another one or another one. So if I'm going to tell a painter to go paint my house, I have to tell them which house I'm talking about. So they're going to be different. I cannot give them a blueprint that says go paint this house. Same thing goes with the output file. So we're going to have the f stream again using namespace std again, and then we're going to use the of stream as a class. Now we're going to use the out stream as our variable. We can change it to anything we want. So this is what I was talking about. Now that I created in a stream as an object, now that I created a car, or a car has been created with a certain license plate number or VIN number, I can go and use the functionality that's going to apply to that. So when I go to a paint shop place and say paint car, the function paint can apply to any car. But now that I took my car, that painting is going to apply to my car. So this open function belongs to the class of what? What class was for InStream? What did we use for InStream? IF stream. Okay, so that open right here is a function that belongs to IF stream as a blueprint. Now we're going to apply it to this in stream that we created. Once again, this is just for your information. You will learn a lot more in your next class. This function or method is going to need a parameter. So we're going to put this parameter as a string. So here we're going to put the double quote and we're going to put this name here. So this function is going to open a file for input stream. So now that I have my input stream, I'm going to be using it just like a cin. I'm going to read from it. Cin was reading from the keyboard. This one that I call it in stream is going to read from that file. Out the stream is the same thing. So I have a stream. Now I have an open. Okay. This open, even though it says same name as the other one, this open belongs to the O stream, OF stream. Belongs to the output stream. It's the same names for the function, but it might be doing different things. So it's going to open this one for the output file. Now instead of cout, I can use that one out the stream, and I'm going to print these things out. So it's going to print this one to the file, then this one, then this one, then this one. How many lines is it printing? One line. There is no ENDL, there is no \n, it's going to be only one line. Yes, sir?
You have to define the one number and the not number?
Definitely. Those are the variables that you're using, definitely.
So it's going to become
Whatever it is. Just like we were having a cout. If I had a cout like this, then when I want to print one number or another number, I had to not only define it, I had to have some value for it too, right? Otherwise it would give me some junk.
So you might switch the order of the not of the numbers and the numbers, it's still going to bring out the same thing, right? Because
Just going to put that one first, I'm going to put the other one second. Remember, the one number is a variable that's going to have something in it. So it's going to print that one, whatever it is in there. So let's say one number is 25, another number is 2.
Because they already stored at the in stream, right?
No. It can be on a stream or it can be not. Doesn't matter. We don't have to always read from the file to write to the file. We can read from a screen and write to the file. We can read from a file and display it on the screen. We can mix it up. It doesn't have to be both of them at the same time. But in this case, you're right. It has been, did we read it? Let me see. Yeah, in this case, we read it from the input file. You're right.
Because it's pretty similar,
Right.
Switches and
So, go ahead.
How does it choose what it's putting in each of those variables? You initialized two variables and then you said in stream and then both of those.
It's reading those.
But it depends what's in the file, obviously.
That's
It
correct.
just goes, how does it chunk what's in the file and decide?
It's going to go read the first number, put it in the first variable. It's going to read the second one, and it's going to put it on the second one. Just like when you do a
space
cin.
or a comma, or it depends how the file is written, obviously.
Right now we have a space or carriage return. So either it's going to be separated by space or it's going to be carriage return. Yes, sir.
You're going to take the first file and organize it where it comes from the lowest number to the biggest number, and read those in to, you know what I mean?
Right, and that's what you're going to be doing in one of your assignments. You're going to take the numbers, you're going to organize it, and you're going to write it to a file, and then you read it again. That's what you're going to do. Not only numbers, you're going to be organizing sentences. That's your next assignment. You should be able to do that, no problem. Right. That's all we're going to be doing. We're writing and reading from the files.
And so you create the file ahead of time?
You can create a file ahead of time, or in real life, what's going to happen? One program is going to come and create this file. The other program is going to come and read this file.
So you can write a program that's going to take in inputs that you're giving it and write a file.
That's
Right,
correct.
basically, and then another program can take that file. The files are like just text files.
For now, we're going to just use the text file. You can technically use any kind of a file, but if you're reading a binary file, what are you going to do with it?
Yeah.
So with this, you can do any kind of a file. But for now, for our purposes, we're just going to use text file for now. And remember, you can open the text file with your editor.
So you could potentially open like a video file, which would just be an enormous stream of numbers.
Right, it's just going to be binary. And when you display the binary is what? Zeros and ones.
Yeah.
So when you try to display it, what it's going to try to do? It's going to try to take those zeros and ones, try to match up with the ASCII table. So it's come up with those weird characters.
That's why.
That's why it gives you those weird characters, because the file itself is zeros and ones. And it's looking at those zeros and ones, okay, can I make sense out of these things? So whenever it matches up with something, then it's going to bring it up and just display. That's what it's trying to do. Yes, sir.
So with text editor,
You can do it in Notepad. You can use your IDE to open it up. It's just a text. It's a regular text. So these files have to actually exist, right? If I want to open a file, it has to be on my disk somewhere. Otherwise, I cannot bring it up. So the first place it's going to be looking at is going to be the current directory. Current directory is what? Is the place that I have my executable, wherever I'm running my program. It is not where I have my source file. It is where I'm running my program. So when we're compiling a program and we get the executable file, that is going to be set in a directory. If I want to open a file, it has to be in the same directory, or I can point it to somewhere else. If I don't point it somewhere else, it's going to look into the same directory. So if it's not there, I cannot open my input file. Can I continue with my program? No. So I have to get out. Yes, sir. Yes.
Yeah, like where are we supposed to put where do we put the file?
Just looking for your executive. We're going to look at it. It's when your final product of your C++ is a .exe. You create a .exe, and you're technically running that .exe. That's somewhere in your project folder. So you're creating an object file. You're going to create when you compile your project, you're going to have multiple file created. It's going to be OBJ file. It's going to be exe file. Those are going to be created. So you want to be sure that the input file is going to be in the same directory. So if you open your window, you're going to see that how does it show it? C++ type of thing. We can look at it.
Also, it's going to be in code blocks. Is what the directory is?
Well, if you're using the IDE for the code blocks, it's going to have, most of the IDEs, they're going to have a directory for your source file, and they're going to create a directory for your executable.
So it'll be right there.
So it's going to be next to each other, yes. It's going to be under a directory of your project.
So we take that notepad text and
Put it in there, yes.
it's kind of like a bin. Almost like a bin.
It's going to look like a bin. A bin is a binary file. exe is also a binary file too, yes. So, next time if somebody come and ask me, I cannot open my file, I should have started deducting points, right? So we talked enough about it, right? For those who listen. So, when we're using a file, we have to close it. That's something with the C++ thing that Java tried to figure it out. So, it's like you leaving your file open, and if your computer crashes or something happened, then you have a file that's sitting over there open. So, we have to close it. Yes, sir.
Some of the
Well, technically, when you shut down your program, when you're done with your executable, it's going to go close everything in there. The problem is if you leave it open, it's just going to be open file. We don't want to do that. Sometimes we close it and we open it again. So I can close it as an input and open it as an output. So I'm going to be writing to the same file. We're going to look at those.
Okay.
And if you find it, let me know what you're looking for. Okay, so this is a basic format, right? We need the pound include f stream over here. We're going to define our variables. The if stream is what? The input stream. I'm going to call it anything I want. In this case, it's going to call it in stream. OF stream is output to stream. We're going to call this one out the stream, or you can call it whatever you want. And now we're going to open. Okay, so the function called open, we're going to have infile.dat, outfile.dat. So infile has to exist because I'm going to open it to read from it. Outfile is going to be created. Doesn't matter if it does exist or not, it's going to delete it anyway. So even if I have outfile, it's going to be deleted. It's going to create a new one. So we're going to figure out how we are good. So we're going to take the C in, we're going to change it to the in stream. We're going to take the C out, we're going to change it to the out the stream, and we're going to close it. So if I get this part, basically that's almost everything that we're going to be doing in the chapter 6. Yes, Danza?
Would we have to create the outbound.dat first before we connect it to the stream?
No. Outfile is going to be created brand new every time you use it. That means it's going to delete everything inside. This is my input file. So what I'm doing, I am reading 1, 2, 3 things. So I'm going to read this one, and this one. 3 things. Because I have 3 variables, right? Then I'm going to do what? I'm going to print these things to my output file. And then I'm going to add those 3 together. 1 plus 2 plus 3 is going to give me 6, and it's going to print it right. What is this going to display on the screen? On a screen, on display. So if I run this program, what do I see on my screen?
The sum of the first 3 numbers.
You don't see anything. Because I don't have no C out in here. Remember, the standard output is a C out. If I don't have any C out, I'm not going to see anything on the screen. You can open this file through your IDE if you want to. Or you open it up through the notepad. So back to the objects. So we have some classes. From those classes we have created some objects. The functionality of those classes has been transferred to the object. So everything that I need has been defined in that object, including the data that I need, including the functions that I need. So every time I create a new object, it's going to have things for that object. A member function is going to be a function that was defined in the blueprint of the class. Now we have that available in every object that I create from that class. So when we say the open function is a member of a function, that means that has been defined in that class. Actually, technically, you can go to the directory of the pound include, which is the include directory. You can open the file and you can look at the text, because C++ is an open source. You can look at all the pound include ones that you're using. It's already in your directory, in the include directory, and there's the source code is available for you to look at it if you want to. So you can actually go and look at the codes for all of these things. So even though we call them the same, they might not be doing the same thing. So for example, out stream is going to open it up for the output, in stream is going to open up for the input. So some of the things is going to be different, but we call it the same, so we know that's going to be opening a file. For us, we don't care what is behind the scene. So if we have different types, they have different functions, so we have some functions in there that we can use, and knowing about those objects, we're going to be learning about those functions. So for example, close was one of those functions that we use already. Open was one of them. So the blueprint of these objects, we call them classes. We're going to use some of this in chapter 8 for the string as a class, and of course we are using it for the file. So we talked about the if stream being what is the type of the in-stream variable object. So this in-stream has been created using the blueprint of the if stream.
Kind of
So
like double is kind of the
it's
same.
like if you're using a data type of double int, now we're using a data type of if string, which is a type of a class. Means it has a lot more, it has a functions in it, it has some elements in it. So it has a data and it has functions in it. In the program, it's a program, it's a class. It's not in the memory yet. Remember, it does not exist. Just like example I told you, car does not exist. So if I say car, doesn't mean anything. So it's the same thing, but we know that there are some functionality related to that. So we know that if it's a car, we can go and paint it. So paint is a function of car. So when I create a car, I know we can paint it. So that class is going to say what functions do we have inside of it. Later on you'll learn how to create those classes. So now I have this blueprint, if stream. It has some function, it has some data in it. So I'm going to create two objects, 1 and 2. Just like earlier I said that if I have a blueprint, I can go create multiple houses of the same blueprint. So in there, they are adopting all the functions that were available in this, both of them. So when I say open, I have to know which one do I need to open. So that's the dot operating is going to be. So dot open of the string 1 is going to go open or call the function open in here. The in stream, the 2 dot open is going to go to this one and open up. So when I go to a mechanic shop, I say fix my car, I have to tell mechanic which car I'm talking about to fixing. So that's the dot operating. It's going to use the object. Object is what is being created. The if stream is not created, so it does not exist in the memory. But in stream 1 and in stream 2 have been created, so they exist in the memory. So we call those member functions that they exist from the class. We are adopting it from the class. So the class if stream has an open function, and every variable object declared of type if stream has the open function. So every time I create one, it's going to adopt the functions available. How do we go with that? We're going to dot. And because the function, the way that we define function in C++ is through the parentheses. So I'm going to have parentheses. If there was no parentheses, that means that would be the element or the data. But if it has parentheses, that means it's a function. So this function can take 1 parameter, 2 parameter, or whatever it needs. In this case, we're only using 1 parameter. So the syntax, we have the calling object, the object that we have. We put a dot, we use the name of the function, we put the parentheses, we're going to put the argument list. Now, if I open a file and for some reason it failed to open, I cannot continue anymore. How does opening input file fails? What is the most common problem with opening input file? This is not the same directory f.exe. What is the most common error for output file? How does my output file fails? Remember, output file, I create a new file every time I want to use it. So in what condition I cannot open up, create a new file?
The disk takes it out.
So if I'm trying to open it in a USB drive, that it's not there anymore. Or I'm referring to E drive or F drive, that's not there anymore.
Or it's not writable.
Or it's not writable, there is no permission. That's good one too. So when we have another function in the same class that is called fail. So we're going to use the dot operator to open it up. Then we're going to use the dot fail. This is a function, does not take any parameter, so it's going to return true or false. That's why I can use it in the if statement. So this is going to return true or false. If it's true, that means this opening failed. If it failed, what we're going to do? We're just going to say something. In real life, we don't put the 1 here. We're going to have some number. So when you call in tech support somewhere in India, and you said I get the code negative 355, they look up their manual and say, oh, negative 355 means this file had an error, and because we know this file was not open, and we know that this file is supposed to be in this directory, let's go figure out what is the problem with the directory. That's why these numbers are for, to define where the problem is.
Do we have to put numbers here? Can we just put characters here?
It takes that number because the return value is going to be integer. Just like your main, you're going to do a return. The return is integer. So what's going to happen if you put a character, if when you're returning an integer, if it's expecting a number and you're putting a character? So that's to open this one. It's going to fail. We're going to have the same type of thing for the output fail. What happened to it? So same template that I had earlier. The only thing we added was if it failed, either the input or output, for now I'm going to put a cout on the screen. And then we're going to exit. So what we have is going to have some bunch of in and cout. We're going to go take those things and we're going to change it to our new stream to read from the file. So the basic type is what? We're going to take all the in, cout. We're going to change it to in file, out file, those kind of things. But some of the things that we had in our standard input-output, we don't need it in the file. So for example, here is asking, please enter a number. We don't need that in the file, right? We're just going to read it from the file. So we were reading a number and we're going to display, this is the number you read. Now we just put it as in file, the number. I would keep this cout to see what I'm doing in my program. While I'm running it, I can test it on my display so I don't have to keep opening the file to be sure it's done or not. I do that, but then before I deliver my file, I'm going to comment all these things out. Either I'm going to change this as a comment or I'm going to just comment it out. Now, I said every time we're creating an output, it's going to delete the previous one. In some cases, we don't want to delete the previous one. We want to keep whatever was in the previous one and we want to append it to the end of it. So there is a second parameter we can put for out the stream as iOS : app. That's going to open for append. So I'm going to open this file. I'm not going to destroy the previous data. I'm going to keep the previous data and I'm going to append it to the end of it. If it doesn't exist, it's going to create it. But if it does exist, it's going to keep the information in it. Remember, if I don't put this one, it doesn't matter if it does exist or not, it's always going to create a new one. So from now on, every time we open, we're going to use that fail. Now we're going to just put the app in there to append it. So if this was my original file of my data.txt, remember here we are just going to be writing out to it. So it's going to keep that one, and it's going to write the rest of it at the bottom of it. So it's just going to keep going to the end of it. Any questions on that one? Back to the file. Yes, sir.
Can you go back to the last one?
Yes, sir. Go back to the previous one. All.
Where it had the code. Yeah. There's only, it doesn't have, the opening of the,
Input file?
yeah.
Yeah, it doesn't use any input file in this one. All it does is opening an output file, and it's going to write this at the end of the output file. That's all it does. It does not have an input file. So the file name is in the C string. C string is a bunch of array character that we will learn in the next chapter about the arrays. So the file name is going to be in that format for now. If you want to ask the file name from the user, you're going to be using this one. It's a char. That means it's 16 character in there. The first one is 0 all the way to 15. It's going to be using the characters. So I can use up to 16. If the user puts 17, it's going to cut down to 16. It's going to pick up the first 16. If it puts 2, then we're going to pick up 2. So the way we're going to use it, we're going to define our file name like that. We're going to ask the user to put the file name. We're going to read the file name like that. And now that we have a file name, we can use it to open it up. So I can have a file name, I can change it to something else. That's a variable like anything else. I can change the value and I can open another file. So in this case, I have the char in file name and out file name, both of them for 16 character. I'm going to read in file name, I'm going to read out file name. I'm going to use those two variables. I'm going to print it out to the screen, see how this goes screen. Then I'm going to use those to open the files, the input file and the output files. And then we're going to just write to that, what are we doing here? We're going to read from that one, and we're going to write to this one. So this is the numbers.dat. This is the sum that's coming out of that, and this is what we're going to see on the screen. So when you submit your files, you're going to be submitting your input file and output file. If it's different than the standard one, I'm going to give you some of these files. I'm giving you some data files. So you can use the data files that I give you. So you don't have to type.
On the website or something?
I'm going to put it on the announcement.
It's on your Blackboard
It is already there?
assignment.
Oh, okay, so it's there already.
The files?
It's on the content of the class, right?
Assignment.
It's under the assignments?
Yeah.
Oh, okay.
What's it due?
It's already there. Huh?
When's it due?
When is it due? Monday.
Next Monday?
Yeah. No, last month. Actually, it was due today. I forgot to post it up. That's why you guys had a free weekend. We're supposed to have done it by weekend. Okay, remember, these are the ones that's coming into your test, next test. For those who are listening, remember, these are going to come into your next test. Remember, all these things are taped in the Blackboard. Is going to be there. Let's go to the last one. Name at least 3 member functions of an I/O stream object that give examples of usage of each. Member functions.
Like the open.
Fail was one. Open was the second one. Close was the third one. Okay, any questions on this section? So we're gonna do bunch of work on this. We got like 3 or 4 programs for this one for this week. We're gonna have 3, 4 next week to figure out what we're gonna do with the test. Any questions?